Today, we are excited to be here with Ari Whitten. Now, Ari Whitten is the best-selling author and the creator of the Energy Blueprint System. He is an energy and fatigue specialist who focuses on taking an evidence-based approach to energy enhancement. He's also the host of the extremely popular Energy Blueprint podcast, which brings together leading experts on the subject of fatigue and energy enhancement to talk about their approach to optimal health. For the last 5 years, Ari has been working with the world's top fatigue experts to develop the most comprehensive program in the world on the science, which is exactly what we love, science, of overcoming fatigue and increasing energy. It's called the Energy Blueprint, and we're going to learn all about it today. So thank you so much for being here today with us, Ari.
Yeah, my pleasure. Thank you for having me.
Absolutely. But the reason why I wanted to have you here in the online summit this year is because there's two main topics that I think are really important for the population of people living with all forms of diabetes. Number one, fatigue. Number two, mitochondria. Many people living with diabetes find that their energy levels go down over the course of time, and most people find that their energy never rebounds because it doesn't matter what system they put into play, how they change their food. A lot of people experience low energy and it gets worse over the course of time. And and I also studied mitochondria as part of grad school, and it can be part of the solution to significantly improving your overall energy. So let's talk about both of those today and really get into the nuts and bolts of it. Now, you've recently completed a comprehensive analysis on the science related to adrenal fatigue, which is this catch-all term that's sort of thrown around when people feel fatigued over the course of time. So can you give our audience a little bit of your take on what is the actual science of adrenal fatigue?
Yeah. So this is I'll preface by saying this is a really huge topic. I have, I think, about 4 hours of lecture online, taking people through all the nuances of the science here. So I'm going to do my best to summarize that 4 hours worth of material in, let's say, 5 or 10 minutes here. At least the key pieces of it. And granted, I'm going to oversimplify and leave out lots of nuances and things like that. But basically, I started in natural health, learning about nutrition and physiology and fitness 22 years ago. I was 14, 15 years old. I was already kind of a savant for it. I had an obsession with it, and I was very good at it from a very early age. And I was extremely interested in natural health and nutrition, and a lot of my mentors from my early years as a teenager and my early 20s were talking about adrenal fatigue. I was seeing books written about it. I was seeing tons of articles online written about adrenal fatigue. I just assumed the whole thing was totally legitimate, grounded in lots of good evidence. And so it wasn't actually until about 6 years ago that I discovered that within conventional medicine, they actually don't recognize adrenal fatigue at all as a legitimate medical condition. So, for example, there's the Institute for the Endocrine Society is what it's called. It represents 14,000 endocrinologist MDs. These are MDs that specialize in hormones, of which cortisol, which is produced by the adrenals, is one. And they have come out and said publicly, adrenal fatigue is not a real thing. There are no scientific facts that support the idea that the adrenal glands get worn out and lead to many common symptoms. So I was very intrigued by the fact that conventional medicine didn't recognize this as a legitimate condition at all. They thought the whole thing was pseudoscience and quackery. Here I was as this hardcore natural health guy who all my mentors were talking about adrenal fatigue. And I was actually irked by conventional medicine, brushing the whole thing off as pseudoscience. So I had an idea that I was going to go write a book called The Science-Based Guide to Adrenal Fatigue that compiled all the evidence and proved that adrenal fatigue is actually substantiated by good evidence. And basically I started digging into the literature and discovered lots of studies that really didn't support the hypothesis on a very basic level. So there's some very basic predictions that come out of this theory of adrenal fatigue. And let me just step back really quick and explain what adrenal fatigue is for people who have never heard of it. But basically, we have these adrenal glands, these glands that sit on top of our kidneys. They produce this hormone called cortisol. Cortisol is a part of our stress response, and it plays a number of different roles in the body. So in particular, it affects the release of stores of blood glucose from our tissues, so it modulates blood glucose levels. It also acts to suppress inflammation. It suppresses immune function. It amplifies some of the other stress hormones. It's involved in a number of different things. So basically, the argument of adrenal fatigue, or the basic theory behind it, is that with acute stress, you sort of get this surge of cortisol and that everything's good, it functions normally. But with chronic stress load on the body for months and years, it taxes this stress response system and taxes the adrenals in particular in such a way that it eventually kind of exhausts or burns out the adrenal glands. They can't produce enough cortisol. And then once they're not producing enough cortisol, you get fatigued, you get insomnia, cravings for sugary and salty foods, and a variety of other symptoms that are claimed to be associated or caused by adrenal fatigue. So again, I started digging into the literature and really realizing, well, first of all, I started with the basic search on like Google Scholar or PubMed. I'm sure you guys are very familiar with doing lots of searches there for different scientific studies. Search for adrenal fatigue. Guess what happened? Nothing came up.
You got zero results for this search?
Yeah, pretty much zero results. So there was like no actual studies on adrenal fatigue, which is pretty bizarre, right? You guys have searched for lots of different conditions. Even really obscure conditions, like you look up Marfan syndrome, or like the most obscure random genetic rare disease that you can think of, you're going to find at least dozens, if not hundreds or thousands of studies on it. You look up adrenal fatigue, which is this super common belief that thousands of people are being diagnosed with by, natural health practitioners every single day, and you get nothing in scientific databases. So that in itself was pretty enlightening for me as someone who had believed in adrenal fatigue for many years. I'm like, why is there no research on adrenal fatigue? This is pretty bizarre. So then I was at a crossroads. Where do I go to look at science relevant to this? I discovered that there are several fatigue conditions, recognized fatigue syndromes within conventional medicine, and that actually, fortunately enough, took me a long time to find it, but fortunately enough, they actually have been tested specifically based on the basic idea of this hypothesis. In other words, they tested the idea of to what extent these fatigue syndromes are being caused by adrenal abnormalities or cortisol abnormalities. Okay, more broadly, what's called the HPA axis, the hypothalamic pituitary adrenal axis. But to simplify, we'll just talk about cortisol. So turns out the idea has been around for a long time. It's not a new idea. It was actually popularized by a guy named William Jeffries all the way back in the 70s, who said fatigue's caused by low cortisol. Let's give people hydrocortisone. That'll fix their cortisol levels and fix their fatigue. It's been around for several decades. It's been tested extensively by researchers all over the world from 1995 all the way through, it's much less popular now, but all the way through 2018, 2019. And basically, after about a year of just trying to dig into the research and find every single study that I could find on the subject of fatigue syndromes and cortisol, I put them all together, and the end result looks like this. There's 59 individual studies in total. Most of these studies, the basic idea of them in the majority of cases is like, take a group of people with chronic fatigue syndrome or burnout syndrome or clinical burnout or stress-related exhaustion disorder. These are the names of these different fatigue syndromes. Measure their cortisol, compare them to a group of normal, healthy controls, normal, healthy people of similar age and gender and so on. Okay, see if there's a cortisol difference, right? The basic theory of adrenal fatigue would predict that if these symptoms of fatigue are being caused by wearing out the adrenal glands and low cortisol, you should obviously see this show up by measuring cortisol levels in people with fatigue versus those without fatigue. Okay, it's the most basic prediction of the theory, most valid, simple way of testing it. Well, there's 59 studies that have tested it, and here's what they find. To make a very long story short, and I actually have all of these listed out in chronological order on my website. So if somebody, it's all available free and publicly. If somebody wants to go to theenergyblueprint.com/is adrenal fatigue real, they can actually see all this, including the screenshots of the cortisol graphs, people with fatigue versus normal healthy people, and the conclusions of the researchers of every single study in chronological order starting in 1995. And 15 of the 59 studies give evidence for slightly lower morning cortisol levels, still normal 24-hour cortisol levels, slightly lower morning cortisol levels in 15 of 59. 11 of 59 show the exact opposite finding, slightly higher cortisol levels in people with fatigue versus those without. And 33 of 59 show no discernible difference whatsoever between people with fatigue and those without in terms of their cortisol levels. You cannot distinguish people with fatigue based on their cortisol measurements from normal, healthy people. Okay, and the actual statistics, there's a number of studies that have kind of compiled the overall statistics such that we can estimate, pretty educated guess, that about 70% of people with fatigue have actually perfectly normal levels of cortisol or even slightly high levels of cortisol levels. And I should also add, even these differences, the slightly higher, slightly lower, still well within the range of normal limits. We're not even talking about abnormal levels. We're just talking about, is there a statistically significant difference that's discernible from normal healthy people? That's still well within the realm of normal, nothing that even remotely indicates the adrenal glands have been worn out and can't produce enough cortisol. Okay, so there is no evidence basically at all from any study, maybe with the exception of like 2 or 3 of 59, that could even remotely be used to argue that the adrenal glands have been have been worn out by chronic stress and can't produce enough cortisol. So basically the simple summary, there's lots of nuances we could go into from here if you want to discuss this further, but the simple summary is the evidence does not support the existence of adrenal fatigue and does not support the idea that adrenal or cortisol problems are the main cause of chronic fatigue.
Okay, so here's a question. You clearly have exhausted the research as far as changes in cortisol levels between those living with some type of fatigue syndrome and those that are not. What about adrenaline? Because the adrenal gland also secretes adrenaline. Is there any evidence to support that somebody with a worn out adrenal gland is incapable of secreting a sufficient amount of adrenaline or not?
It's an interesting question. And in all the interviews that I've done on the subject, I've never had somebody ask me that. But it's a logical question given that the adrenals do produce adrenaline. Right. The answer, for the most part, as far as I can tell, is almost no studies have even tested that. Okay. It doesn't seem to be a significant hypothesis, and it doesn't seem to have been tested. I'm sure that you could find some that also tested adrenaline levels, maybe here or there. I might be wrong about this because I just haven't seen much research at all, but I think part of the reason I haven't seen much research on that is I think that the issue with it is adrenaline is extremely hard to measure accurately. It's extremely short acting. It like acts within seconds and then disappears from the bloodstream. And so something like that would, I think, be almost impossible to measure accurately.
Okay, so I think our listeners are going to be very intrigued at this point. So if that's not the issue, what all these people struggling with chronic fatigue syndrome, or what has been labeled adrenal fatigue, what is actually going on?
Yeah, great question. So I first want to clarify to anybody who's listening who has been diagnosed with adrenal fatigue, who has identified with that diagnosis. I am not saying I'm not saying your symptoms are not real. I'm saying that your symptoms are almost certainly not being caused by your worn out adrenal glands or your cortisol issues, unless you have a rare autoimmune condition called Addison's disease, but that's totally unrelated to the concept of adrenal fatigue. So your symptoms are real, but they're probably not being caused by your adrenals. So what is causing your symptoms? Well, there's a pretty vast body of literature linking lots of different factors to chronic fatigue, and or even to acute fatigue for that matter. Personally, I think the best way to conceptualize the story of human energy levels and the spectrum of whether you're severely fatigued or highly energetic really centers around mitochondria. Mitochondria are cellular energy generators. We have 500 to 2,000 of these in virtually all of the trillions of cells in our body, and they are providing 90+% of the energy used by virtually all of the cells of our body. So in a sense, what could be a more direct and simple way of kind of explaining this energy story than looking at our cellular energy generators? And not only is it logical and kind of common sense, but there's lots of evidence to back it up. And one of the key pieces of this story is Dr. Robert Naviaux's work around the cell danger response. And one of the big insights from this concept of the cell danger response that he's built out is that mitochondria are not just these mindless cellular energy generators that, you know, the kind of the powerhouse of the cell that we were all taught in high school and college biology, but they are actually much more than that. And they have this other role that most people are entirely unaware of. And that role is in cell defense. So they are energy generators as one of their two key roles, and they are environmental sensors as their other key role. And the key part of this story is that the more that they pick up on danger signals or threats or stress signals from the environment, the more that they switch out of energy mode towards defense mode. These are two modes that mitochondria can function in, and they're mutually exclusive. So the more you switch on one, the more you switch off the other. So Dr. Robert Naviaux talks about this as peacetime metabolism. So peacetime metabolism is synonymous with energy mode. It means your mitochondria are not picking up on a lot of danger signals. They're saying, hey, everything's good, we're healthy, we're safe, let's pump out lots of energy. But the more that your mitochondria start picking up on danger signals in the environment, the more that they shift out of energy mode into defense mode. They shut down energy production. So what are some of those danger signals? And there's a whole bunch of them. So everything from poor nutrition can be a big factor, and there's lots of different avenues that poor nutrition can result in mitochondrial shutdown. Certainly inflammation is a big one. We know that literally elevated inflammatory cytokines in the bloodstream, basically the molecules of inflammation, directly shut down mitochondria. They act directly as a signal to mitochondria that danger is present. We need to shift out of peacetime metabolism into defense mode. We know that if you have a diet that doesn't support good gut health, for example, or you have other factors that impair gut health that cause dysbiosis of the gut, that an imbalance of beneficial and pathological bacterial species and other microbes in the gut, that can shift the amount of toxins being produced in the gut in a variety of different ways. One powerful one that's been linked with a lot of harm is called LPS, lipopolysaccharide or endotoxin, linked with diabetes, cardiovascular disease, neurological diseases, many, many other diseases, and chronic fatigue, I should mention. So that endotoxin, especially when combined with increased gut permeability, starts leaking into the bloodstream in increased amounts. Well, LPS is that endotoxin from the bacteria is directly a signal to shut down mitochondria. In addition, if you have gut permeability, you're going to have more undigested food particles that are getting into the bloodstream that are causing immune and inflammatory reactions, which are, again, another avenue that's going to shut down mitochondria. So that's a few of the avenues related to nutrition and gut health. There's many more avenues. Another one is, for example, heavy metals in the diet can directly inhibit mitochondrial respiration. Different prescription and over-the-counter drugs can do it, can damage mitochondria. There's actually a site called MitoAction that lists out a huge array of different prescription and over-the-counter drugs that damage mitochondria. We also know one of the big factors is psychological and emotional stress. And there's actually an emerging field called mitochondrial psychobiology, where they've done now a number of studies looking specifically at the link between the mind and the mitochondria, and how what's going on psychologically and emotionally can be translated to the mitochondrial level literally within seconds. So there's that level. There's also circadian rhythm and sleep, which is a huge layer of the story. I think probably the single most common cause of fatigue is circadian rhythm and sleep problems. And then there's a number of other layers. So light is another layer to this story. Lots of nuances there. One of the books I've written about is called The Ultimate Guide to Red Light Therapy, something we could talk about. But there's even more to the story there. My next book is on light more broadly. And then one more factor I'll mention, something called hormesis, which is basically how transient metabolic stressors interact at the mitochondrial level. There's lots of cool layers to build out there if you're interested in digging into that. So to wrap up this big picture paradigm, basically lots of these different environmental lifestyle factors can, if they're not dialed in appropriately, can converge at the mitochondrial level in such a way that leads to the mitochondria detecting those danger signals, shutting down energy mode or peacetime metabolism, and shifting into defense mode. And when those mitochondria, the more they shift into defense mode and shut down energy mode, the more that's happening at the cellular level, of course, the more that you, on the big picture, you level, are going to feel the symptom of fatigue.
Okay, this is fascinating. I feel like I could take this conversation in 20 different directions, so I'm going to refrain from trying to spitball questions at you. But when we talk about mitochondrial health, one of the things that we also like to do with people living with diabetes is explain to them that the function of mitochondria inside of primarily your muscle tissue has a huge impact on your insulin requirements. And when mitochondria are super efficient, then your insulin requirements go dramatically down. When mitochondria are inefficient, then your insulin requirements go up. And that goes true for people who are injecting insulin, like Robbie and myself, or for people who are not. It puts a toll on your pancreas when your mitochondria are inefficient. But again, this conversation that we talk about is specifically located inside of the muscle. But correct me if I'm wrong. What you just described is that mitochondrial health is phenomenally important in tissues all throughout your body, correct? Your brain, your liver, your thyroid gland, your sexual organs, your gut, you name it. So is it true to say that when you refer to mitochondrial health, you're referring to head to toe multi-tissue mitochondrial health?
Yes, 100%. And, I always get caught in my own sort of thoughts as I'm explaining this, because I'm deciding how much of this story I want to leave out, which you have to leave out because we could otherwise be here for 30 hours. But one of the big layers to the story is mitochondrial dysfunction and mitochondrial shutdown is not just linked with fatigue. It's linked with, over the last 10, 20 years, there's an accumulating body of research linking mitochondrial dysfunction with almost every major chronic disease, from obesity and diabetes, type 2 diabetes. I don't know about type 1. Maybe you know more about that than I do. You might have looked at that more than I have. To heart disease, to neurological diseases, to many types of cancer. Almost you name it. And if you go type in Parkinson's, mitochondrial dysfunction, Alzheimer's, mitochondrial dysfunction, heart disease, diabetes, you'll find lots of research emerging there. There's even the mitochondrial theory of aging, and there's an accumulating body of evidence showing that mitochondrial dysfunction is one of the major pathways to the process, the rate of aging at the cellular level itself. Now, that occurs since we have mitochondria in basically all of our cells, with very few exceptions like red blood cells, for example. But our brain, our heart, our muscles, our liver, our kidneys, pretty much everything. The more you have mitochondrial dysfunction in those tissues, the faster those cells are going to age. And you're basically, yes, is the short answer, that mitochondrial dysfunction through all the tissues of the body is what I'm talking about.
Great.
So you mentioned the red light therapy and light therapy in general, and that is fascinating. So can you give us a quick summary of what that is and how people could actually implement it in their life?
Yes. Okay. Quick summary. How do I do that?
All you have to do is take 10 hours worth of content and put it into 5 minutes. It should be really
Yeah. So the story of light is very interesting. Most people have no real understanding of the power of light and how important it is to human physiology. So we think of light as like light is the absence of darkness. I flip on a light switch in a room so I can see things. But what we don't normally think of light as is something where these rays of light are penetrating into our body and doing all kinds of things at the cellular level. Okay. Some people kind of have an inkling of that if they think about it with vitamin D. Most people at least know a little bit of that story. So we know that going in the sun stimulates vitamin D synthesis in our skin. We know that vitamin D is really important for, I mean, I'm speaking for the average person. Vitamin D is important for like a variety of things, maybe immune health and calcium absorption and things like that. But it's actually a hugely important compound. And then maybe some people also know the story now of some aspects of circadian rhythm. So if you get too much artificial light in your eyes at night, it suppresses melatonin and impairs your sleep. Okay. Even with just those two layers of the story, there's still lots that we could dig into. But there's this other part of the spectrum of light called red and near infrared light, and it's literally visible red light. Right? So like if you see light that's in the red spectrum, those are red wavelengths of light. So when we look at a blue sky, it's blue wavelengths of light. So there's this visible spectrum of light. This is part of the electromagnetic spectrum. It's the colors of the rainbow. That's what humans can see with our eye. And then there's a much bigger part of the electromagnetic spectrum that's outside of what humans can see. So we have everything from X-rays and gamma rays on one end. Then we get into the visible spectrum. Then we get into things like microwaves and radio waves. These are all parts of the electromagnetic spectrum. So there's the visible light spectrum. There's something called near infrared, which is just outside of what humans can see with our eyes. And then there's far infrared, which is like what you would experience in a far infrared sauna. So some saunas use that technology to heat you up. But this specific part of the spectrum, red and near infrared wavelengths of light, have some really interesting and unique aspects to them. One of the biggest ones is that more so than really any of the other parts of the light spectrum, they penetrate into our body. A lot of the other parts of the spectrum, whether we're talking about blue light or ultraviolet light or far infrared light, these really stop very much at the surface level of our tissues. But red and near infrared light penetrate inches deep into our body. So for example, when you were a kid, you might have took a flashlight and shined it up to your hand and noticed the light coming through your fingers and your fingernails on the other side. And what you would notice if you pay attention to that is you notice that it's specifically red light that makes it through there. So all the other parts of that spectrum are being filtered out, and it's red light that makes it through. Now, why is this fact really interesting? Well, this light is not just this inert substance or inert sort of thing that doesn't do anything. It doesn't just penetrate into our body and do nothing. It actually interacts with our cells, and it interacts with our mitochondria in profound ways. So there's some layers to the mechanisms of this story, but to simplify, I'd say there's three basic mechanisms. One is, I'll actually just explain two for the sake of simplicity and not getting overwhelmed with mechanisms here. One is it interacts with a receptor on your mitochondria called cytochrome C oxidase, which is part of basically this chain of components that's involved in the mitochondria's ability to produce energy. And that cytochrome C oxidase requires binding with oxygen in order for the mitochondria to produce energy efficiently. But sometimes, for example, in the presence of too much chronic stress or just non-optimal lifestyle or environmental factors, the mitochondria can kind of get overloaded with nitric oxide. And that nitric oxide binds to the same site that the oxygen does and kind of plugs it up. It prevents the oxygen from getting in. So what red and near infrared light do is they penetrate inches deep into your body, through your cellular membranes, through your mitochondrial membranes, inside of your mitochondria. And those photons of light are hitting those cytochrome C oxidase light receptors and kicking out the nitric oxide and allowing oxygen back in so that mitochondria can produce energy more efficiently. Okay, so that's one layer of the story. So if you think about what I just said, it's pretty interesting. We're used to thinking about plants, taking in light to, kind of photosynthesize and produce energy. Most people are not used to thinking of their body, their cells, as being light responsive, and that their body could take in light photons and use it to produce energy more efficiently.
All right, this is beyond interesting. It's fascinating. You're like a mad scientist here with all this knowledge.
So there's some other cool layers to the story too. I'll leave out one of the mechanisms, a little complex, but one of the other layers to the story is sort of the central dogma of biology for a long time. It's still actually taught as the central dogma is basically you start with DNA, then you move into RNA, then you move into proteins. Okay, so the basic idea is like DNA is the big boss. The nucleus of the cell is what houses your DNA. DNA is your genes. Your DNA is what bosses around, gives orders to everything else, and tells everything else what to do. Well, what we've since learned is actually mitochondria and their role as environmental sensors and picking up what's going on in the environment is actually really important in communicating back to the nucleus what genes to either turn on or turn off. And this is a process called retrograde signaling, where the mitochondria communicates to the nucleus about what genes to express. And this red and near infrared light is one of these signals. There's lots of signals that work this way. So for example, like physical exercise, many dietary factors also involve the mitochondria picking up those signals, communicating back to the nucleus. So for example, if you eat like pomegranates and blueberries and various adaptogenic herbs and green veggies and things like that, there's actually a signaling effect where the mitochondria can pick up on some of those phytochemicals, signal back to the nucleus, and is switching on certain anti-inflammatory factors, switching off certain inflammatory factors, and so on. So red and near infrared light can do this as well, and in various different ways. So they signal, the mitochondria pick up these signals from the light, they send it back to the nucleus, and it's part of it is what I just explained. Part of it is switching off signals that are involved in chronic inflammation. But even more interestingly, what it does is it's sort of a signal for cellular healing and regeneration. And it switches on genes in the nucleus of those cells that are involved in the production of proteins that stimulate cell growth and regeneration. Okay, and those are tissue-specific compounds. So they go by, they're different compounds in different tissues, in other words. So in your brain tissue, you stimulate the production of things like nerve growth factor and brain-derived neurotrophic factor. In your muscle cells, you stimulate protein synthesis, and you stimulate things like local IGF-1 at the cellular level to ramp up protein synthesis, for example, in response to like weightlifting. If you do weightlifting paired with, so weightlifting itself increases IGF-1 locally in those tissues, but red and near infrared light actually stimulates it further. So you can get increased strength and muscle size when you pair it with exercise in that way, and faster healing of those tissues as well. If you use it on skin, you ramp up the proteins that are involved in collagen and elastin production. So this is why there's a whole body of literature around the effects of red and near infrared light to have anti-aging effects, anti-wrinkle effects on the skin. As well as wound healing and injury healing effects. So for example, this can be surface level in the skin, or it can be, cuts and scrapes and things like that, or it can be tendon and bone healing as well. So you can create increases if you've got a fracture, for example, or a bone bruise, and you use this, or you've got tendonitis and you use it on those tissues, you stimulate the production of growth factors that speed up the healing of those injured tissues in this way. So basically, red and near infrared light, to make a long story short, is a sort of signal for human biology for cellular healing and regeneration.
Okay. So again, I'm trying to digest all this, Ari. It's a lot of information here. Now, how would somebody use it? Like if like, what is it, 10 minutes, 20 minutes, you buy a device? Like if somebody wanted to actually put this into action, how does it go?
Yeah, good question. So, well, one easy way, especially for someone like you or me that lives in Southern California, is get sunlight, because part of the sun spectrum is red and near infrared light. And that, in combination with firelight, so if you're sitting around a fire in the evening, you're getting a dose of red and near infrared light from those sources. One of the big problems in the modern world, though, is most people are not getting nearly enough sun, and most people don't sit around a fire at night anymore. So there have been a number of companies that have created red and near infrared light technologies. So for decades, actually, this has been around for decades. There's over 5,000 studies on this. So if anybody's sitting here skeptical of what I just said, please understand there's literally over 5,000 studies that have been accumulated over decades. So you might be wondering then why you haven't heard of this. Well, the main reason why is that it's really just becoming popularized in the last few years because of some of these technologies, specifically LED-based technologies, coming to the forefront, making it widely available for the average person to buy for $400 to $1,000. You can get a home-based unit. Whereas prior to the last few years, this technology mostly existed in the form of lasers, which you generally could only get in various physical therapists' office and chiropractors' offices and dermatologists and anti-aging clinics and things like that. And those devices are $5,000 to $30,000. So it just wasn't accessible to the average person until a few years ago. But with these LED devices, in fact, I can just show you an example of one. I don't know if this is video, but for people watching this video, they can see this is a simple example of one of these devices. You literally just plug it in and flip on the switches to turn it on, and you sit in front of it. So if you want to, or lay next to it, or whatever position, a lot of them are set up like on a wall or something, so you'd stand next to it. I like to put them on the ground and lay next to them. But if you wanted to do like an anti-aging treatment on your face, literally this, like it's not that complex, right? You just sit with this, 12 inches away from your face and do it. If you wanted to use it for fat loss, you'd shine it on the area that you have kind of an excess fatty deposit that you're looking to try and get rid of. Obviously doesn't work in the absence of also doing, things on the diet and exercise and other lifestyle factor front. But I use it a lot actually for muscle recovery after exercise. So I weight train, I rock climb, and I surf. So I do a lot of exercise. And literally this probably cuts the recovery time from any exercise you do in about half by most estimations. And there's even like studies where they've looked at average recovery time from not just exercise, but from injuries in athletes, like college athletes who are injured for various reasons. And they look at how fast they get back to the playing field with and without the use of red light therapy. And it literally cuts their recovery time in about half in most cases. So it's really remarkable technology. And the way I explain it is really like this. If there were a drug, a pill, a pharmaceutical that were scientifically proven in over 5,000 studies to have anti-aging effects at the skin, to stimulate fat loss, to enhance recovery from injuries, to heal damaged tissues, to speed recovery from physical exercise, to enhance the adaptations, both in terms of fat loss, in terms of muscle gain, in terms of strength, in terms of endurance. And there's even research relevant to what you guys are doing around benefits from exercise in terms of improvements in insulin resistance, and how this can pair with exercise to nearly double the improvements in insulin resistance that you would normally get from exercise alone. And a whole host of other, improvements in energy, decreases in chronic inflammation, improvements in joint health, decreases in pain, et cetera, et cetera. If there was a pill proven to do all of those things with virtually no side effects, this would be a $1 billion blockbuster drug. This would be like one of the most successful, if not the most successful drug of all time. And your doctor would look at you and say, you're absolutely freaking nuts. You are crazy if you don't take this drug, because this drug is amazing. And that's literally what this is. It's really an amazing drug, but it's not a pill from a pharmaceutical company. It's light.
Ari, this is fascinating. I actually just purchased a red light on Amazon while you were talking. You sold me right off the bat.
Actually, I know you're joking, but you do got to be careful as far as what you purchase, because there's huge differences as far as power output and pricing of these different lights. Big differences in quality and big differences. I mean, literally 10, 20-fold differences in terms of what's called the irradiance, which is how much light is actually being emitted from the device. Not to mention that there's a huge range of options as far as how big of a device you should get.
Okay, this is, yeah. So as you were talking specifically about the effect of red light on mitochondria and the ability of cytochrome C oxidase to be able to absorb that wavelength, and then it brought me back to my graduate school days, because I used to study mitochondrial health for years and years and years. And as you were saying that, I was literally just like, wow, this is fascinating. And what I think this also uncovers, one of the things is that, like you were saying, if this was a pill that you could put into a bottle and a pharmaceutical company could market it, it would be the biggest drug of all time. But the world in which we live doesn't necessarily give as much credence to things that seem, alternative like this. And if red light therapy has even half of the benefits that you described, which I fully believe it does, it's still an incredibly effective tool that people can implement inside of their arsenal of lifestyle improvements, including, like you said, changing the food that you eat, changing how much you move your body, and also improving your sleep quality. So, what I love about what you're talking about here is that this is a sort of multifaceted approach. You're not going to get better mitochondrial health just by drinking a certain type of water, right? You got to do a whole lifestyle change. And I think for most people, it can be, intimidating to be like, oh, well, I have to add this and this and this and this. But in reality, if you kind of do it in a stepwise fashion, then you can really assemble an incredibly effective lifestyle that truly has lasting benefits for many years.
Yeah, you're 100% right. And I think there's a lot of thinking out there, a lot of reductionism to the one thing. A lot of people like to kind of reduce everything down to, all disease or all this type of disease is caused by this one thing. It's all caused by toxins. It's all caused by chronic infections. It's all caused by diet. It's all caused by, whatever the thing is that someone is very attached to. And then their treatment becomes very focused on just that one thing. And the reality is there's lots of big contributors to the chronic disease epidemic. There's certainly lots of big contributors to the type 2 diabetes epidemic. There's certainly lots of big contributors to the chronic fatigue epidemic. And I'm a fan of looking at all the causes and really looking at how we can optimize all those different variables. Certainly some are more important than others. Like I would definitely prioritize nutrition way ahead, and circadian rhythm way ahead of like going to look for like really exotic, much more rare causes. Like, do you have chronic Epstein-Barr virus or chronic mold exposure or something like that? Yeah, I think looking at a lot of the different factors that I mentioned so far are very, very important.
Yeah, it's phenomenal. So give our audience a little bit of insight here into how they can learn more information from you. Tell them what books can they buy, where can they find you, and most importantly, how can they become raving super fans of you like we already are?
Yeah, thank you. So my books are available on Amazon. The last book I wrote, which came out in 2018, is called The Ultimate Guide to Red Light Therapy. And it's basically an in-depth guide to everything that I just explained, much more detail on the mechanisms, huge compilation of research around all kinds of different benefits, and then just a very practical, here's how to use it for various purposes. Here's the best devices to buy and so on. I also have a free online article that's a very short version of the book So if somebody doesn't want to go buy my book, I think it's actually the Kindle version's on sale for like $3 right now. So it's not a big expense. But if somebody doesn't want to spend those $3, go check it out on my site, do a search for Energy Blueprint and red light therapy, and the article will come up. And then I also have lots of lots of information, I should say, on how to optimize your energy more broadly, outside of just light therapy in that specific topic. So if somebody wants to go to the energyblueprint.com, we have a free masterclass there on it basically covers 6 secrets to optimize your energy levels.
So this is great. So basically, if people want the unabridged version of what you just talked about, and they want to listen to you talk for a longer period of time and get a little bit more in depth with a lot of these concepts, they can go to your website and they can get in that masterclass. But all right, thank you so much for being here with us today. I mean, I honestly feel like we could sit here and talk for many, many hours, because this is just the tip of the iceberg.
Yes.
But I think what you're bringing up here is actually something that's very important, because like we said earlier, people living with all forms of diabetes end up suffering from this, quote unquote, adrenal fatigue or chronic fatigue that may be mislabeled, and allowing them to understand that there's actually either a lack of research showing that adrenal fatigue is a real thing, and an abundance of research showing how you can improve mitochondrial health and energy levels is fascinating, because I don't know that many people that know this information, and you talk about it very openly and you do a very good job with it. So that's a long-winded way of me saying thank you so much for being here today. We really appreciate it.
Yeah, thank you so much for having me. And I agree. At the end of the day, it doesn't matter what you call it. You can call it whatever you want, but here's how to fix it. That's what matters.
Absolutely. You got it. Thanks again, my man.
Yeah, thank you guys.